Record. So I just gonna go do a recap, like in a short recap. So what exactly we discussed, and right now I gonna discuss part two. So yeah, let's see. Yeah, so we do have yeah, as we discussed, the hard disk has the magnetic hard disk as a disk and platter, and however SSD has the all the chips inside, the EPROM and other chips. So or the flash memory. So we are identifying the disk location, the data writing location with the inode data. And
Excuse me, sir? Is this the Indian scam one or what?
hey, hi Jackson, do you have any doubt, man?
Why you look like that?
Is this like, is this the Indian helpline? The Indian scam? Like, the scam line?
Hey, no, we are discussing some Linux
Man,
related.
Jack, you said yo, bitch. Man, Jack, shut your bitch ass up.
Yeah, I guess I need to change the meeting bridge to share in private. So yeah, in Linux, the disk will start like dev.sda. The disk will show up like dev.sda, and we do have three partitions. Like when we started the OS installation, we have an option. So we have dev.sda 1, 2, and 3, and the default file system is ext4, and we can do a mounting. So whatever is the file system is there. So yeah, whatever is the slash root file system is there. So we can do a mounting at home, var, or temp, however we want. And similarly, what happens if the disk got filled up? So if we are in a virtual environment, so what we can do, we can increase the disk space of the original disk space from 25 to 30 GB. And we need to make a couple of changes after doing that. So we will go through that. What exactly? And also we can add a new disk, and we can attach the things, but we need to convert it into something called LVM. We cannot do it directly. Okay. Yeah, and what exactly we did last time, once we increased the disk space, we went and deleted the partition and re-added it. So we made sure our main partition is the last one. This is one and this is two. So here we deleted and re-added, so it will get the new latest disk changes, the increased disk changes. So how does it looks like? Yeah, this is how it looks like. So the end of the sector, right? The new end sector will get updated. So that's what we did. And yeah, as soon as you deleted and re-added with the exact same starting point, your data remains same. There won't be any issue. What we notice is even though we did this step, like deleted and re-added the partition, we need to make sure to do one more step so that the disk changes will get reflected. Okay. So yeah, let me start the VM.
Deleting means we just unmount and re-edit
No,
the.
actually, whatever you're seeing, right? So the disk platters, whatever we discussed. So you have a logical thing. So we are not deleting the data. We are basically deleting the partitions logically. So what to say? As I told, so when you delete a file, right, it has a pointer to the reference ID to your hardware. Okay. So you wrote in a file like hello world. So it has some particular bytes written to the disk. So those bytes will stay as it is. Uh, your file, whatever you're seeing in your virtual logic file, so it has a pointer to the hardware. The whatever is the bytes written to the disk, right? There is a pointer. So when you delete a file or a partition, the pointer will get deleted. Okay. So your actual data stays as it is. So what exactly we are doing? We have to follow the rules. Let's say it is written in this particular the bytes. Okay, 4028 to 5000. Okay. So you made sure to maintain these files. No one comes and written on top of this. Your file stays as it is. Okay. So it is the same thing for partitions as well. Yeah, it is the same thing for partitions as well.
Yeah,
Let's
I
like,
think that class. I will recap that session.
yeah, yeah. So what exactly we did? We made sure to note the first and last of the partition. Okay. The first one starts with 133. The last one, it is okay. So what we made sure, like the next time when we are starting, see, forget about this one, SDA3. Okay. So when we are creating a new partition, when we are deleting it, okay, and adding a new partition, so the extended one will go 644 and all. That's okay. But the start point will be same.
Same.
So that your data will stay as it is. It won't get deleted. Did it make sense?
Yeah.
Yeah. So yeah, note down the first and last bytes of the sector actually, and delete the partition and add new one. Okay, and enter the first byte from the nodes and make sure space is extended. So the last byte will get increased. Okay, so till here we did. We have to do from F disk this one. Okay, so till here we did, and what happened to our VM? If I go and see, right? Uh, yeah, I'll just do a restart. Okay, so yeah, just for the recording sake, so we do have SDA1 and SDA2. So we to increase the disk space, so we increased it from our virtual box. So we need noted down first and last bits of the partition. We deleted and re-added through fdisk. And when we are adding, we added a new partition with the first byte number. And at the end, we did this command, resize to fs, so which increased the file system. So this is how it is. What? I think it's got cleaned up. Yeah. So this command will take care of increasing the file system. So, and now we are going for the LVMs. So why exactly LVM coming is, so we have SDA1 as a one disk, SDA2 as a second disk. So in order to do that, so we have to take care of these three things. Okay. So yeah, we will install LVM first. After update, sudo apt install -y LVM. Yeah, here it is. Created. So yeah, as per the diagram, so what we're gonna do, so our hard disk comes stays here actually. So dev SD1. So our hard disk is here below the PV. So what we're gonna do, we're gonna create a physical volume on top of it. So it's a virtual object still. So we'll create a physical volume object. So that would be PVS. Sudo pv create dev sda1, and another one is we want dev sda2 sdb. So okay, cannot open mounted file system, cannot use sda1, it has a signature. Okay, so what I'll do is mounts. Okay, this. So what happened is the sda1 is still as it is a mounted one, so I gonna unmount it. Okay. You- Yeah, definitely. Gonna try a couple of commands. What from? Mhm. So I'll try reboot. So the problem here is our partition still mounted, this dev SD1. It's still mounted. I'm unable to unmount it. So what I'm doing is I'm doing a reboot to make sure to get it back. Okay. So if it's not working, I guess I need to remove the FS tab. But yeah, let's see. Sudo umount/temp. Sudo vi etc FS tab. So I'll comment it out. Go reboot. Let me restart the session. So LSBLK. Yeah, so I don't have the temp anywhere mounted again. The SDA1 is free. So I'll rerun the command again. So the command would be, yeah, there should be wipe out the disk. Actually, I didn't do, but let me do the wipe out command as well. Okay. So wipe fs. Okay. Okay. So yeah, sudo pv create a1 devsd tvs. Yeah, am I still audible, guys? No issue, right?
Yeah, you're audible.
Yeah. So, okay. So as we told, so first we created the lower object, which is PV. So the physical volume related object. So we were able to delete, we cleaned up everything with the wipe command. And then we were able to unmount the data and we created the PVs. So the next step would be to create the volume groups. Okay. So that would go like this. Sudo vg create vg data. So our names devsda1 and devsdb. So why I am picking these two is these are the two items which are gonna merge. Okay. So I highlighted these. This is the one and this is the one I gonna merge here. So this is 6 GB and another one is 5.5 GB. So if I merge total, it will come like 11 GB somewhere. Okay. So sudo vgs. So this is the VG data. This is the volume group. So as I told, I combined these two and it made as 11.62 GB. Okay. So the next step would be logical volume, right? LV. So sudo LV create FNL 100%. Okay. So here, what exactly we can do? We can specify how much is the amount we want. Okay. So that will go like this. See, the command says 100%, right? Okay. 100% free, FNL, LV temp, and VG data. So instead of 100%, what I'll do, I'll give 70%. Okay. Sudo LVS. So what happened here is, so I can give 100% as in 11.62 GB. Instead of that, I gave only 70% here. That means in the roughly 12 GB, right? The 70% is roughly around 8.14. So it created the logical volume of 8.14 GB. So there is a reason I created it. So our merge data now it is 8 GB, but what is the total capacity? The total capacity is 11 GB. So we can still extend it later. That's the reason I thought to show you. So we have LVS has been created. So the next step would be mounting it. The next step would be formatting it. Actually. So sudo mkas ext4 s. Okay. So we have the LVMs created. Now the LVMs are mounting in a different way. So what we'll do, sudo And if you see the name, the LVM name is same here. LV-temp, VG data, LV-temp. So both are same and both are of same size, 8.1 GB. So sudo mkfs.ext4, what I'm supposed to give. So dev VG data LV school. So the partition has been done. Let me verify. Let me mount it again. So mount. So we did mount into the temp directory. So let's go back and double check it. So lsblk. So the mount went into, it's a type LVM and the mount went into /temp. Okay. So if I give df-h, so yeah, the mount went into /temp. So still the questions remain same. So we have LVS and VGS. So yeah, we have the volume group. It's showing 11 GB, but we used only 8.14 GB here, 8 GB basically. So how we can extend it? So extend it use. So I think it is LVM extend. We think I'm gonna reuse the same command. So here it is the 100% free, right? Okay. Sudo LV extend. Display logical volume. I'm copy pasting it. That's the reason it's the data is showing up like this. But yeah. So this is the command for LVM extend. So after we did extension, right? So we need to we need to tell the file system that we extended the file system. Okay. So that will go like this. Yeah. I think, yeah, I think it's reused it. So earlier it is 8 GB. Now it is 11.6 GB here. So let me check the DF. Okay. The DF is still the same. So in this case, what we'll do, we'll reuse the resize as command. Okay. Resize to fs. Yeah. Now it's increased to 12 GB. So that command also I'll paste it here. Yeah, let me summarize the steps, what exactly we did. So, and then you can go ahead for it if you have any questions. So for LVM, we gonna merge. So one particular disk or one particular partition. So we can do a merge. So what we did, we wiped out these two disks. So one partition and the second disk, we wiped out it. And then we removed any mounts, whatever we have. And we created these three items. So PV and yeah, we created a PV and then we created a volume group and then we created it can be one, it don't need to be two, but yeah. So it can be volume group one and we created a logical volume. So these two things will represent as a logical volume everywhere, as in LVM. So that's what it's showing up. If you see in the LSBLK, so list out the blocks. So the VG data temp, right? So the both are same. They're being represented for the slash temp. We mounted for slash temp. So that is it. So I'm gonna generate a fs tab command. Okay? Generate. Okay. Guys, you have any questions? Whatever we went through, right? So, do you have any questions too? The LVM or the disk partitioning, whatever we gone through yesterday, the last class and today's class. So, do you have any questions?
So how do we create multiple volume groups for a single physical volume? Like, I mean, the command would be same, right?
Yeah, the command would be yeah, and
So what
also
yeah,
go ahead, please.
yeah. Like, so what will be the use case for multiple volume groups on same physical volume?
Uh,
Like, I mean, I didn't get like what will be the difference between the two volume groups?
Let me check. I was also not sure. This is the first time I created it from scratch. Okay.
Okay.
Yeah, to partition it. However, you cannot use two VGs on same disk or partition, as you noted. Yeah, I think it's for using for different partition, different mounting and all. But let me see. Okay. Okay. So according to ChatGPT, what it says is, so here one logical volume I'm using for slash temp here, right? Okay. So according to the so what we can do, we can create second VG2 and we can create VG3 and we can start mounting the data as in so here we use the logical volume for temp, right? So similarly, we can use this one for slash home or this one for slash boot. So we can reuse it as we merge the whole data, right? Whole disk, right? So from the merge, we can take multiple volume groups and we can mount it as multiple directories. So we can bring out multiple mounts. So here we bought only one mount. So we can, and the disk also we can keep adding here, right? So we can add SDCC in case if we need, or we can extend it the same thing. So we'll have the PVs as multiple PVs. So from there, we can create multiple volume groups. So as in isolation, from there we can host it as a multiple mode. Does that answer your question, man?
Yeah, so for example, now this physical volume is 11 GB. So VG1 and VG2 will share the same 11 GB, right? So there is no definition that this VG1 will have 6 GB, for example, and VG2 will have 5 GB. Nothing like that, right?
No, nothing like that. So I think when we creating VG group, there should be an option. Okay. So we have VG create, right? So in the VG create, we are giving this like data where it should supposed to come from. Okay. Yeah, max volume groups, physical extension size. So yeah, we can specify the size. What is the size we want for this one, this volume group?
Okay.
So yeah, from there we can control however we want.
Okay, got it.
Yeah. Any other question, guys? Okay. Let me show you one small thing then. Okay. We are out of the time today, but yeah, I'll cover two different topics. So that will take like roughly 5 minutes. So So we have different structures. So we are not going to discuss the structures and all. So what we are discussing is we want to discuss the types, key features, right? So yeah, they didn't give complete information. Okay, let me. So one thing is each one, right? Okay. So you have something called inode data. Okay. So let me show you how does it looks like. Okay. So you have LSLTR. Okay. ls hyphen I. Okay. So if you see, you have how many inodes is like 1, 2, 3, 4, 5, total 36 it's showing. But if you see this one, 5 plus 5, 11. So you have 11 different inode for these directories and all. Okay. So you have a limitation of how many files you can create. Okay. So let's say you are running an application. The application might create some temporary files. If application might create temporary logs and all, right? So you do have a max number of files, how much it can create. Okay. So max inodes. So it's not max size. Okay. So it's not max size. So we are talking about the number of files, max number of files. And also, what is the largest file a file system can create? Okay. So usually the Linux usually go for ext4, but let's just roughly go through the differences. So yeah, this is what the FAT32, the old one, we used to create 4 GB file. This is like very old traditional file where 4 GB is the max. So later point, we have the 256 TB is the one. And for ext4, we have 16 TB. That's the max one. And we have journaling enabled for these two file systems. And if you are coming back, yeah, this for large files install compatible. So earlier file systems ext2, ext3, it is compatible and doesn't support secure deletion. I'm not sure of this feature, but we'll go through that. Yeah, from here, what I can see is the two features. What we are, I think file naming is there. So two features. What we are looking for is this one. So what is the max number of files a file system can create? Okay. So, and largest file a file system can create. So mostly this is the feature which we are supposed to focus on. So it in production, usually you might not exceed this limit. So very rarely, if the files are like lakhs and all, so that's the time you will breach this limit, max number of file systems and all. So that time you might need to clean up your files or move the file somewhere. So need to take some action. So that is one thing. And second item, as I told, we have df and du, two commands we have. So let's go through that. So df usually shows the disk file system, so where and all the mounts are happening and all. So you have something called du. So du shows the disk usage. Okay, but if you see, right, the du is listing out in the current directory what and all files are there and how much it is. Okay, so yeah. I gave du-sh, so it's sorting out in the current directory. It's listed out this. Kind of messed it up. Yeah, there should be a way you can control the recursive. Okay. So yeah, it is. What's happening is it's listing out each and every file here. So let's say as a sample, I'll take the etc. Like I'll go to etc. So du-sh, what it does is it will sort out the files based on the file size and all. So du-sh. Yeah, and it's listing out multiple things. So what I'll do, I'll give max depth is equal to 2. Sorry, and max depth is equal to 1. So if I provide max depth is equal to 1, it gonna go to the first folders. Okay. So if I provide max depth is equal to 2, so it's going inside the child folders. So through the depth command, we can control how much deep it can go. Okay. So we have sh as well. Let me. Okay, earlier you used to have a sort option, but not sure why exactly I don't have sort. So sort -r. Yeah, this is what. So let me write down the command. So du hyphen h will list out the file system, file usage on disk. So you have this command, du hyphen h with sort minus r, sort hyphen r. So this is what will store the files and in the recursive order, however you are looking for. Okay. And in case you are looking for max depth, right? Yeah. This is how you are looking for the files. So why exactly this command is needed here? So let's say you got an alert like your disk space got filled up. Okay. So in that case, you know only the directory which got filled up from here. You got slash or you got temp and all. So from there to dig further, you need to use this du-h command. So that's how you know, okay, one of my file system got increased. So you will know which folder has my like top usage. So, and then you can go there and dig further. Okay. Let's say I have this local. Okay. I can run the same command. Yeah. Now I can see which folder has the highest usage. So from there, I can go and control the, like, I can go and clean up the data. So that's how it is. So yeah, here I'll conclude the disk partitioning thing. In the next session, we'll try to do the troubleshooting of disk usage, like disk related issues or CPU related issues or memory related issues. So we'll introduce the trouble in the production and we'll try to troubleshoot it. And then we will go for APT and those kind of things like package management and all. So I think we are like very close to concluding the Linux basics. So from then onwards, we will try to go through the next topics. Like I'll start with Nginx or Git. So we can try through that. We'll try with Git and then we'll go for Nginx. So yeah, any questions, guys?
Yeah, Sasi, just a basic question. So
Sure.
we need to take a backup before we use LVMs, right?
Right.
So is there any specific way to take the backups or any specific file systems
No,
or
why we are supposed to take backup? That's the first reason we need to see. Okay. So yeah, this one, right? This by default itself, it's not LVM. Okay. So it's a normal disk, normal Linux file system. So later you wanted to take it as LVM, right? So if from this partition, what you can do, you can take two different partitions. You have SDA2 or SDA3, which is mounted as, this one is mounted as stem. The other one is mounted as root. So you can take partition, you can take a backup. Usually we rely on the CP command itself, CPR, but we have a tool, rsync. That's a better tool. So using rsync, you can take a backup. And it's little fast. It will recheck what are the files existing, and then it will write only the files which are not existing. So using rsync is a better tool for backup. And it's a standard command, rsync the source and rsync destination. So you'll get the data. You have an options rsync-avz. So whether do you want to source and rest. So whether do you want to see the files which you want to overwrite all the files and all that kind of options will come over here. And also rsync, you can run it against host. So instead of destination, you can specify a server as well. SSH at the destination, right? So that your data will copy to any remote server. You have a remote data backup server, right? So you can copy your data there. And if you are in the same network, it won't take much size and all. So yeah.
okay, thanks.
Yeah. Any other questions, guys? du-h or the LVMs or disk partitioning, whatever we seen.
Can
Oh.
you share those commands for future reference?
Yeah. See, LVM commands I written over here. Okay. Yeah, the VM increasing command, the disk increasing command I written over here, and the final one is du-h. So yeah, I'll try to increase the documentation, but yeah, I written the commands left side. Is there any specific command you're looking for?
No, I just want to use them for practice. So
Yeah, sure. Yeah, I think with this I'll conclude it here. I'll update the recording. I think I need to combine 2 recordings, but we'll do that. So yeah, thank you guys. Thank you so much. Thanks for joining. And if you got to know anyone who are like looking for any learning groups or something, ask them to, keep an eye regularly. So
thank you.
yeah, thank you.
Thank you.
Thank you.